I manage an aircraft repair shop, component repair shop. We were on Konkoma at MacArthur Airport. I'm not a teacher, but I do some teaching of aircraft repair. One of the interesting things about repairing aircraft is everything mechanical on an aircraft has a time limit. Anything that moves, turns, vibrates, has to come off the aircraft when it hits 1,000 flight hours, and it's got to be completely rebuilt. So that's what my shop does. Anything that's not mechanical, like a transistorized voltage regulator, can stay on the plane until it fails. So one of the interesting things that we work on are AC generators and alternators, same thing. Let's just do some basic AC generation. In order to make an alternating current, this is all Tesla's claim to fame, all you have to do is move a bar magnet near a coil of wire. If I make a coil out of it, move the magnet past it, the magnet is forcing the valence electrons in one direction and then the other as I move the magnet past. You can check the left-hand rule on Google, and it'll tell you which way the electrons are being pushed. If you want to make the generator more efficient, instead of one wire, make a coil of wire. So now you've got more electrons being pushed, and that's a higher voltage. You want to make it simpler to operate, you turn the magnet near the coil of wire, and you can use something like a windmill or a water wheel to turn it and make get power generated. Now to make it even more efficient, instead of a 2-pole magnet turning in front of the coil, in most generators they have a multi-pole magnet. Now, this rotor comes out of a Gulfstream generator, and it's got 6 poles on it, north-south, north-south when it's energized. And this is out of an old carbon brush type generator. DC voltage is fed in to the 2 copper slip rings and energizes this rotor north-south, north-south. I've got one hooked up to a 12-volt computer battery, and when I energize it, it gives you a very strong north-south indication on a compass. Or if I put a cast iron bolt next to it, it sticks, and you'd be hard-pressed to remove it. And this is only with 12 volts. On the aircraft, it's seeing about 28 volts. So it's a very strong north-south rotor, obviously rotating. The jet engine is turning it at approximately 8,000 RPM. Can you turn on this backlight?
Chucky, those ones like
Those back, that's by you, Rich.
Those ones
Is
like
this one? Your far left switch.
Oh, there we go.
Okay, to figure out the frequency of any type of generator, the frequency is equal to the number of poles divided by 2, so you've got a 6-pole rotor, times the RPM over 60. It's turning at 8,000 RPM, so the frequency of most aircraft generators is 400 cycles per second. The electrons are bouncing back and forth between the copper atoms 400 times a second. One of the advantages of AC power is that you can use transformers to raise the voltage up. Typically, the voltage coming out of a power plant is 250,000 volts, and you can run a small city off of a small gauge wire. Now this is 00 cable, is rated about 300 amps. Multiply that by 250,000 volts, that's the wattage through one cable. That's the advantage of AC power over DC. DC, you need a cable as big as your leg to just light up a small city. This rotor is turning inside of this stator. The stator fits over the rotor. It's got a very close clearance. There's only about 10 thousandths clearance on both sides. The tighter the fit, the more efficient it is. And again, to increase the efficiency, instead of one coil of wire in here, there are 3 coils of wire 120 degrees apart. So as the rotor turns, you're getting 3 pulses of electricity out of these 3 wires. And if you could look at the 3 pulses, if you had an oscilloscope with 3 inputs, you'd see the three pulses are 120 degrees out of phase. The top would be 120 volts plus, minus 120 volts minus on the bottom. So that's what three-phase power looks like. Usually it's used to run very large motors. And the way the three coils are arranged in here is this diagram here. There's a center connection with the three coils, and the three outputs here are the red, green, and black wires coming out. The center point is ground or neutral are the three blue wires soldered together here. Pretty much every home and factory gets at least two power leads and a neutral. From a power lead to a power lead, you get 208 volts. From a power lead to neutral, you get 120 volts. So that's how you can get both voltages into most houses. Run heavy machinery, you need all three phases for large synchronous motors. When this is turning on the aircraft, these carbon brushes bring in the DC exciter voltage to this rotor. Interesting how it's constructed. It's one long wire. It starts at one slip ring, comes down and winds clockwise around the first pole, comes up, then winds counterclockwise around the next pole, and so on around the rotor, so you get north-south, north-south. That's Tesla's original design, probably almost 100 years ago. One of the limiting factors is the carbon brushes. The carbon brushes can last about 1,500 hours, but the generator has to be pulled at 1,000 hours and completely rebuilt. The other limiting factor is the ball bearings. The ball bearings have a life limit as well. If a ball bearing fails, the rotor grinds into the stator and destroys the generator. One of the reasons that aircraft is so reliable is that everything mechanical is pulled and rebuilt before they fail. Let's see. That's a brush type generator. Then the Westinghouse engineering people figured out how to make a generator without the carbon brushes, so they can run the generator a lot longer. What they designed was a three-stage generator. Here's the rotor out of a brushless generator. There's a circular 14-pole magnet, and it's attached to the rotor. They both turn. This small magnet puts out about 21 volts AC out of its corresponding stator. This is the stator, and it rotates inside it. You get an AC voltage coming out of it. That small voltage goes to the voltage regulator. The regulator takes that small AC voltage, turns it back into DC with diodes, feeds it back into the second stage exciter, which fits over the rotor. So while this is turning, you now have an AC voltage being generated in the top of the rotor. That's the second stage. What's really brilliant is they put diodes in the rotor, so now you have that small AC voltage turned back into DC, and that's fed into the main section of the bottom of the rotor. So there's no more carbon brushes to wear out, and now you have north-south, north-south going into this four-pole main rotor, which is turning inside of its corresponding stator. This rotor turns a lot faster than that one. This rotor is rated 20,000 watts. Any one generator can run the whole plane. So if one generator fails, they just have relay logic and switch over to the generator that's running. One of the really cute tricks we have of testing the rotor is, since we can't turn it on a workbench, is instead of putting DC into this from the regulator, we can put a small amount of AC into it and fool it to think it's turning. So I can put some AC into the top.
Is that a variac?
Yeah, it's a variac. And now we get north-south, north-south again on the compass. And with this simple little trick, we're checking that the exciter stator is good, the exciter rotor is good, the diodes are good, and the main winding are good, all with that little trick. Saves our technicians a lot of time. One of the other safety factors on an airplane is a current transformer. The 3 wires coming out of the generator, each one is a typical feeder cable, goes through this current transformer to the distribution box on the airplane. And inside this current transformer are 3 separate coils of wire. And if any feeder cable is overloaded or shorts to ground, it sends a pulse out its connector to the regulator, and the regulator will shut off the exciter voltage to the generator. Well, these are on the airplane, they're also in the power plants. If any phase is overloaded, this is what senses it. Anytime you travel on the road and you see the high voltage wires at the top of the pole, there's always 3 wires, because there's the 3 coils in the stator. Let's see, something on a separate note of aircraft safety. Every nut and bolt on the aircraft is held in by one of 3 ways. The easiest is just a lock washer, a large spring lock washer. The second would be Loctite. We probably have 30 different kinds of Loctite. We once got fined for having an expired bottle of Loctite, $2,000. The FAA is brutal.
That's the biggest bottle of Loctite I think I've
Yeah,
ever seen.
Yeah, I know. Yeah, we have little bottles too, but this particular D is very popular. It's very strong
The
Loctite.
red and the blue, I think.
Yeah.
Blue is a little lighter.
I didn't know there was an expiration date on those things.
Oh, yeah.
Neither did I.
Oh, yeah.
Like, how long is it?
Well, like 1 year from manufacture date.
So you used one of those in a short time?
Right, well, yeah, we have the little bottles too for the ones that aren't as popular. But yeah, the FAA comes in, they check the Loctite, they check the greases, they check the oils. We have one guy that just keeps track of all the expiration dates.
Is it expiration date on oil?
Aviation oils and aviation greases as well.
Yeah. That's one thing your car to stall out.
The third way to secure any bolts and nuts is by safety wiring them. A lot of the nuts and bolts have tiny little holes drilled through the top, and we'll tie the bolts together with stainless steel wire. It's an interesting skill that aviation mechanics have. They take a piece of the stainless steel wire, obviously it won't rust. I'm gonna put my glasses on. And they'll feed the wire through the hole of the top bolt, thread it clockwise around the bolt. Then we have special twisting pliers that hold the wire and twist. You just pull it and it twists. I don't know if you can see that.
Oh, that's
These
cool.
are really cool pliers. And the FAA says it's supposed to be 7 twists per inch. 7 twists per inch.
I think I want one of those to twist on my bread bag closed.
There you go.
That's the only use I would have for
I
it,
can
but.
become or become an orthodontist.
Oh, okay.
Then you take the loose end, put it through the lower bolt, go counterclockwise around the bottom bolt, grab the wire again. You gotta learn how to use chopsticks. And then twist it the opposite direction. It has built-in cutter as well.
But they're not cheap.
Oh, they have them in
Oh,
Harbor
they're,
Freight.
yeah, you can get them for about $30, and then twist the sharp ends out of the way. Beginners at this have a habit of stabbing themselves with the wire. It's like as sharp as a hypodermic. So my guys are running for the first aid cabinet, I see a little spot of blood coming out of their hands. And that's how you safety wire typical bolts on an aircraft. Here's a cabin pressurization valve. And it's got all this fancy safety wiring around the edge. This is what pops your ears when the plane is going up and down, this control valve. And then we have a hot air control valve, also a lot of safety wiring on it. Some of the valves we work on have about 30 different safeties on it. It takes a technician about an hour just to do all the safety wiring. This valve controls the hot air that's bled off the middle of a jet engine, and that hot air goes to the leading edge of the wing to prevent ice. It's called a de-ice control valve. Just one thing, the rotary permanent magnet, if they lose their flux, we can remagnetize them back to full saturation. We have a matching stator that it fits into, and we can put 1,000 amps in about a half a second through this coil to remagnetize this magnet, all 14 poles. And as Rich said, come out and visit us. There's a lot of interesting.
Gotta come out and visit. I mean, it took me a while to get out there. I'm embarrassed how long it took me to
A
get there.
lot of interesting things
You
to
gotta
look
come
at.
see.
A lot of heavy rotational testing, hydraulic testing, pneumatic testing. It's very interesting to see what we do. Very few people know what it takes to keep aircraft flying these days. And I always joke, when your plane needs service, give me a call.
Thank you, Steve.
All set?